Good afternoon again. Welcome to the Hydrogen and Fuel Cells and Batteries Group Exhibit 2016. My name is Robin, and I will be having a conversation with Dr. Alexander Dyck, Head of Division Fuel Cells at Next Energy, and his topic being Contribution from Research as Added Value for Technology Development and Commercial Success.
Hello,
nice
Robin.
to see you. Thank you very much for being with us.
Pleasure to meet you.
Thank you. Okay, so we'll just start with the difficult questions right away. Can you please tell us a little bit about Next Energy?
Next Energy is a public-private partnership research institute. So we're making research for different organizations or even companies that trust in us and give us contracts to make research for material research up to system development and even how we could influence or give positive response to system demands we have in the future. And we are around about 125 employees in Oldenburg, where the level of Earth is really flat. But that's an advantage in case we can see trends coming, where even some days in front before they arrive, really.
That's an advantage. And this is an independent organization, I believe?
Yes, the site name is EWE Research Organization. So it's our main sponsor is an energy supplier in the Northwest. The main advantage why he gives some money to a research organization to look for the future demands of energy supply is that they have already 75% of renewables inside their grid, and they have to give answers how they will have to develop their infrastructure, their grid, to make the next steps to 2030, 2050, and they are still the stablest energy grid in Germany. So without a power drop, so we don't in Germany we want to have this stable conditions anyway.
Great, thank you. What does Next Energy focus on mainly? What type of research?
We have some different divisions. So we are looking on the solar cells on the roof, where we look for less material consumption and higher efficiency, like all others in the solar panel fields. And then the second is we look on the overall energy system, so how the influence could be. Or how systems like fuel cells could be integrated into a house or even a small area of a city. And even cities are changing over the next decade. If you look, if there are new houses were built, the gas suppliers think about if there's still a need to put a gas pipe to the houses in case the energy demand for heat is lower and lower, and the future demand is so he has no selling perspective for natural gas in the near future. So from 2020 on, there's a strict limitation on that. So power is the main source he has to sell, and there is a demand for the customer and even the supplier he can choose where you like to get your energy from. And the third division is the fuel cell, where I work for. I'm responsible for. The fuel cell has also energy storages inside. We had the fuel cell itself from materials to systems, and we look also for predicting models into the future for houses that are now in the field and will influence the future trends. So high efficient houses, so where the insulation is quite high, will have less energy demand for the gases. So we are part of the problem of the future. And at the last division is they look for energy predicting tools in 2030 and 2050, how the energy system must restructured, where new pipes or lines has to be built up to make the energy floating, coming from the wind from the north. And even in Hanover, where the wind is lower, so the power transmission line must be built up and to bring the power to here, to have some light.
For our interview. So I like how you say that you predict the future. That's part of your job, Next. In a way.
That's always nice to look in the future. I have not large great bubble on my desk, but you have to see how the developments happen, which fuel cell types or which energy demand, even if you are at home, which energy demand you will have. And maybe if you grow up and have or buy 2 or 3 new computers, it will change your energy demand at home. And this energy demands can be predicted. So even from the future trends of how much installations you have, how much intelligence your house get, so the smart homes will influence also the future demand of the houses from the electrical side of you. And there is also the input for the fuel cells. So if you look, fuel cells have the highest level of electricity in competition to heat. So the heat demand get lower and lower in the houses, so it's the fuel cell system. And there are systems on the market with up to 60% efficiency, so they fit quite perfect then to the future houses where the all electric demand is requested.
Thank you very much. I see that you brought us here something that looks a little bit like spaghetti to me. Perhaps my background's not technical.
Yeah,
if you mind explaining what that is to us, please.
Yeah, there's not spaghettis, but we try to make one of the components inside the fuel cell is a GDL. And we have some partnerships from funded projects where there are some mathematical models, and they say how the GDL looks like, so straight fibers, nearly no connections. And in research organizations, you have some fundamental large equipment. And we have, for example, a micro CT, where you can look through materials in a different way, and you see that they are not straight somehow. So this is a small part of a GDL where the spaghettis are lying together, and you can see also how they are connected. You can see how much volumes are inside this. Well, in case this has to make the gas transport and the water transport or water steam transport out or to the membrane. And this makes it quite easy to calculate this. And also you have some compressions from the channels. So you have uncompressed and not less compressed parts. And so you have material changes inside the fuel cell. And we could not only predict it, we could measure it under real conditions and even see degradation aspects. So if you make too much compression on this fiber, you know it if you bite on it, so it breaks. The same is if you have too hard compression by a bipolar plate with a hard element, then you can cut it. And if you are on the membrane side and you have a cut off a fiber, and you can peek through. And so we can even see pinholes inside an MEA after some working hours, or delamination from the MEA after use under the channels. And we can predict or see how degradation happens. And degradation is one of the efforts where we try to figure out where the future demand will be. So some systems, if you buy a heating appliance, you say or estimated 60,000 hours of working time or 15 years of lifetime should be for sure, and not even without warranty. You expect that you don't have to renew it before this time. So this lifetime has to predict it somehow, to estimate it. But how you estimate it 15 years of lifetime? Nobody wants to wait 15 years until he can sell the first product. So we build models where we can predict the lifetime of MEA on single cell level, and we can show which conditions for the fuel cell are limiting this lifetime. And if you predict or avoid some conditions that are bad for you, I don't have to smoke and I don't have to drink so much alcohol, so I maybe get 80 years old. So that's the thing we did for the fuel cell.
Fantastic, thank you.
With spaghetti.
What is it used for? Like, is there like a main field where you use it, or is just one of your projects?
It's inside the project. We provide this data or these assets for the customers. We are not the GDL supplier. So the GDL suppliers are the customers inside the project, where we can say which needs from the market are to fulfill and which technical hurdles from the GDL. So there are directions of the machinery inside the GDL that could help to enhance their development of the material. And this helps to reach the overall lifetime goals inside even the projects or even the development for the project, so that the car can run like outside, or the fuel cell in the houses will run over the lifetime we estimated and we predict.
Predicted. And speaking of the projects, I know that you have, I have three here, one of your many, I'm sure. One of them being System, the other one Eureka, and D2 Service. So if you could speak to all three of them, that'd be great, please.
Yeah, we are on an international fairground, so we have European projects. I'm a little bit proud about it that we have already finished our first project from the idea to the last step, and with this even success, but I think we will come to this. It was quite a hurdle to overcome all the steps, and we learned a lot from every step, even the fuel stage undertaking, where you can develop things together with industry, and that's I think the main reason. So we develop, you can say I'm a think tank and I look for higher level of light, whatever, but we are always in conjunction together with companies, and we try to help them and assist them to get to this market approach where they have to go. Only if the companies are full of fields and sell products to the market, we could. There is also a benefit for us to provide them further research to even enhance their products for the near future. And I think they will not be finalized, even if you can buy now your first fuel cell. I think there will be a next step. And in System, we developed or try to help develop a high temperature stack that it's able to reach or operate at 160 degrees, and also the lifetime is there the most important part. So lifetime is directly connected to costs, and costs is the things that we have to get down to be more easier available for the customer, or to get off the limitations.
Everyone wants a long lifetime and low cost.
Yes, for sure. So nobody wants to have a maintenance worker every month in his house. So I have to get some spent holidays in case my system does not work. So we want continuous operation. So we accept for the cars that we have only to go for maintenance every 30,000 kilometers. And if I see my maintenance staff for every year, it's quite okay, accepted. But for more, it will not be accepted. And the maintenance has been fast. And this is also one approach from other project we have. It's D2 Service, where maintenance should be optimized. So the maintenance costs are time and parts that you have to change. And normally the maintenance service should have all parts that he has to replace on board of his truck, so that the maintenance could be done in 15 minutes or half an hour. So, and then for 1 year it's enough. And you don't want to pay him to read to the books which parts he has to exchange, especially on this unit. So he has to exchange even some parts from different. So, and you could see this also from some micro CHP units that are on the floor here, that there are components, equal components inside, and this helps also to bring the costs down. So even you have a storage for maintenance costs, and if the water equipment is the same for all micro CHP units.
So reliability playing a big role in your field.
It's the customer that like to have reliability. So it's not a gadget that we sell. So if you have just a recharger for a cell phone and it doesn't work for the second time, you throw it away. That's not the politically correct answer. But if you have a CHP at home, you want to have a stable product for some years. If you buy a car, you want to have it for 5 years, no problem with it. And you want to use the car when you have some business plans with this. You want to drive somewhere and make business or whatever, so you don't want to stop somewhere in the desert and say, okay, the car failed. I think we are not in space, so where failure is no option. It could happen, and even it's a young technology, and there could be something on the way. But it's for the people. It's important they have some persons who feel responsible that it works in an appropriate way. There will be more struggling parts at the early beginning and as a new technical approach.
Thank you very much. And you have some of these models at your booth, which I'll mention at the end. So it's really important that people come and visit your booth. And so in relation to energy storage, can you tell us about, I believe, redox flow battery? And how is that the same as a fuel cell? How is it different?
It's called battery, but in part, it's you have fluxing media getting on an MEA, something like that. So it's something like a fuel cell. So it's something in between. So the main part why it's in my opinion, it's something like a fuel cell. In case you have one thing that's responsible for the power, and you have the tanks that are responsible for the energy content you could supply, and that makes it flexible for different approaches. So the energy storage can't especially fixed on the demand you have in your house or in some else's house. And this is maybe an advantage against other energy storage. We see from the field or from our field tests that energy storage can enlarge to use what you earn from your roof. And it makes it attractive for some customers.
Of course, you're going to be independent.
Something like that. Hopefully, independency. The last step of independency is very expensive. But to say I'm use 90% or 70% of my own energy, that makes me sometimes a little bit happy.
Oh, absolutely, made me very happy. How can Next Energy systems work in the marketplace?
So from the product. From the projects we have, sometimes also projects or real products come to market. So from the Eureka project, for example, the middle temperature fuel cell stack has a market launch somehow in the next days. And also high temperature stacks are available, bipolar plates. We try to assist from the research, the market acceptance for some parts, and this products come with our help and assistance from the research side to market, and you can even find some booths where we cooperate with them and buy finally products. And also we had some modeling part where we predict the future demand of houses, and this will be available from the standard organization like DIN, where you can buy it to predict your future houses from the architect side. And this is only in a resolution of 50 minutes. And we will make this available end of the year in a higher resolution. And this is important again. If you take a water cooker and you put it on and it takes 3 kilowatt. In a 15-minute slot, it's only 600 watt. And if you have a 1 kilowatt CHP at home, okay, it works. But in reality, it's 3 kilowatt. It doesn't work. So, and you could not cover the full energy content. So you need a grid connection. And this tools to predict the energy demand for the future in a higher resolution is an important tool to even get the added value from some technologies you could implement. Even so, for example, in energy storage, that it's available to connect this above energy demand or power demand you have to fulfill. And there we see some added value from the models we could supply.
Thank you. I'd like to end on a great note. So you could tell us a little bit about maybe a latest success story, one of your projects perhaps that came to completion?
Yeah, the examples I just give are where we can provide some gadgets for the market. So the models are available and will be available at the end of the year. And the products from other companies are also available now or available soon. Where we can provide our technology with technical equipment like analytics, like predicting tools, and even some characterization effort. So that's also an example. So we will develop a standard for fuel cells that you can compare. You as a supplier will give me a fuel cell stack and you say this has 300 watt, and I as a customer see only 250, and then we have a critical content, or we'll discuss about that. And we have some examples to measure such a stack in a continuous way, and we have an agreement, okay, these are the numbers we have to fulfill, and then you have 280 or 300 watt, and I will measure the two. So no even a flow chart or quality issue from the customer to the supplier. And this that's why quality we see as one of the major issues, to have a stable product over the lifetime, but also the first implementation of the project. So that it's not only put it together and it may work, we put it together and it works. And that's a success story. Nobody can afford 20% of waste by the production. And this is a future need. If we ramp up the production now and buy the products that are on the market now, then it's a must and not a nice to have.
Not a maybe, but a for sure. So next energy is in booth D57, just a few blocks back there, a couple of blocks. So please feel free to go by and visit Dr. Dyck.
And the team.
And the team, please, who's sitting back there. Thank you for joining us. Thank you so much for joining us as well.
It's my pleasure.
Thank you. Perfect. Up next we have Stefan Reike from Etogas, and the topic will be power to gas, hydrogen, and SNG. Thank you very much.